Hey folks, welcome to Tim's Off Grid. Today I'm going to be working on insulating my garage door. This garage door is not typical. It's a lot larger. So if you have a non-typical garage door, you can't just walk up into Lowe's or somewhere else and just buy a kit. So this garage door is about 9 feet wide, and it's over way over 8 feet tall. It may be about 10 feet tall once you get up there. So when you run into these non-standard garage doors, there's a couple things, and it's in the spacing of each one of these compartments. They're also not your standard spacing. So I end up with a spacing in each one of these compartments that is about 50 inches, and inside rail to rail is 24 inches. So 50 by 24, and then the internal spacing is like 1 and 9/16. So some weird stuff there. So I would need something like 1.5 inches, but I couldn't find any 1.5 inches. So what I ended up going with was what they had in stock. So I got your Johns Manfield, and this is your 1/2 inch, and it's foil faced, and it's polyiso continuous insulation. So I got that. Its R value over here at 1/2 inch is 2.9. So not awesome, not terrible. But if I couple it with the 1 inch over here, and I got the 1 inch Polypro, and if I don't have an airspace, it's 2.8. If I have an airspace, it's 3.85. So there's a couple different things you could do. I could have gone with like 2 1/2 inches and then use some dowels to build an airspace in there, and I could get better insulating. So the Polypro board by itself is 3.85. If you're able to add in 3/4 inch airspace, you can get another 2.8. So you could get 6.65 out of this with an airspace. I'm not going to have an airspace, so we're going to go with our 3.85. So let's just round out to 4, plus what we had over here, which was 2.9. We'll round out to 3. So we're going to say R value of 7. So what I'm going to do next is I'm going to cut a couple of these pieces and test fit and see how the first piece goes. Now, if you're in a situation like I was in, where these are like 50 1/4 on the horizontal, and then they're slightly under 24 on the vertical, cutting these in half, you end up with 24-inch lengths. And see right there, I was putting them on reversed. The foil side needs to point out, but I fixed that. Now, I ended up with 48-inch lengths, and I had to start shaving off some of the 24-inch, so this was going to work because it was too tall. Now, with the 1-inch, it's a bit easier for you to force this in there, and you'll see that a couple times I popped a corner. But with the 1/2 inch, you've got to be more concise with the cuts because you can't really bend the 1/2 inch. Now, you could use something like a straight edge or something, and you could use that as a guide to pop in the top. And you'll see for the most part, this was working pretty good. And then I would offset the 1/2 inch for the gap on the 1 inch, etc. The problem was when I got to the top, and I was working on the top, and I cut a little too much off, and that's when I had already bought the aluminum duct tape, and I used it to hold the top in. So that worked pretty well. So I'm pretty pleased with this and the 2 layers that went into it. I could tell right off the bat it was holding more air in the space that was warmer versus having more of the radiation of the cold air or convection of cold air that was taking place. This was a long time coming. I had put it off because I just didn't feel like getting into this one and cutting it, but all in, it only took a little over an hour and it was done. So I'm probably going to have to come back and trim the 1 inch on those top left piece because the 1 inch is a little too tall. Just be prepared to, use your